Okay guys, so today I'm going to show you how to solve a problem using bisection method. Okay, so let's say you have a question. Locate the root for the function ln x4 minus 0.7 using 3 iterations, and with also given initial guesses of xl equals to zero point 0.5 and xu equals to 2. So you are asked to solve this problem using bisection method, and given you need to do 3 iteration, and given also your lower x and upper x. Okay, so now first things first, if you still remember the steps that I give in my PowerPoint, there are like 3 steps of bisection method. The first step is you need to estimate, or you need to have initial guesses of XL, but in this case it's already given to you, so you can skip that. So we move on to the second stage, which is you now have to calculate the value of your XR. This is only estimation, all right? So XR, according to the formula, is actually XU plus XL divided by 2, and this is 0.2 plus 0.5 divided by 2. So here you will get, oh no, sorry, this is not 0.2, this is 2, okay? So here you will get 1.25 as your first estimate of the XR. Then, if you still remember the third step of the bisection method, you need to make some evaluation, which is you need to calculate your FXL times your FXR. Okay, so here you need to make judgment. So the result of the calculation of these two values, you need to see whether it is more than 0 or less than 0 or equals to 0. Now, if it's equals to 0, then this one is your final answer. But if it's more than 0, you need to do another iteration. If it's less than 0 also, you need to do another iteration. The difference between these is just that for the next calculation, you will have your XU value equals to your XL, and for the less than 0, you will have your XU value equals to your XR. Oh, sorry, if it's more than 0, your XL equals to your XR. If it's less than 0, your XU will become your XR. So let us check what is the value of FXL and FXR for this first iteration. So FXL is just a matter of substituting your XL into the function. So here ln XL is 0.5. 0.5 minus 0.7 from here. Just substitute XL into this function. So here you will get, please do your calculation, okay? Minus 3.472588. Okay, now please be reminded that for all numerical calculation, please keep a lot of number of decimal places. So preferably 5 to 6 decimal places. Okay, now it's time to calculate your FXR. So again, you just substitute your XR here, 1.25 into this equation. 1.25 minus 0.7. Now you will get 0.192574. So if you times your FXL and FXR together, FXL times FXR, which is your here FXL, minus 3.47258881 times here 0.192574, you will be getting minus 0.6687308. Okay, so obviously this is less than 0. So if it's less than 0, so you have to move on with your second iteration. So if it's less than 0, what you have to do is, therefore, you need to set your XU equals to your XR, which is in this case, your XR here is 1.25. 1.25. Now, for the second iteration, your XL, what is the value of your XL? You know your XU, but you don't know your XL. But XL will remain the same, 0.5. Okay? Remain the same. For this second calculation only, remain the same. Alright, now so we can calculate the new value for the root, which is XL plus XU divided by 2. So here 0.5 plus 1.25 divided by 2, you get 0.875. Okay guys, so let's continue. So now that you got your estimated root in the second iteration as 0.875, so you need to do the next step, which is the evaluation, whether you are setting XR equals to XU or XR equals to XL. So how to do this? Again, you have to calculate your FXL times FXR, see whether it is either more than 0 or less than 0 or equals to 0. Okay, so your FXL is just negative the previous calculation here, negative 3.72. Okay, so it's just a matter of substituting 0.5 into the function. So you get your FXL equals to negative 3.47259, and your FXR is now, you use this value, okay, so it's ln 0.875 to the power of 4 minus 0.7. So this one you will get negative 1.23413. So FXL times FXR, which is this one, negative 3.47259 times this one, negative 1.23413. So you will get 4.28561, and this is obviously more than 0. Okay, for this part, actually, you are not so interested in the values you are getting, but rather you are interested in the final sign of the answer, whether it's negative or positive or equals to 0. So this is the most important thing. You need to highlight this, okay? You need to put this like in a box or maybe something like that. You need to highlight. Okay, so next, the third iteration. So therefore, since your FXL times FXR is more than 0, you can then set your next XL to XR because it's more than 0. So if it's more than 0, XL equals to XR, which is your XL now for your current calculation is 0.875. Let me just get another piece of paper here. Is it? Okay. Now that you have the third calculation, you have your XL equals to 0.875. You need your XU. So XU will remain the same, which is 1.25. Okay, XU 1.25. Again, you calculate your XR, XL plus XU divided by 2. 0.875 plus 1.25 divided by 2, and you will get 1.0625. So this is your new XR.
Okay guys, so since the question only asks for 3 iteration, so this will be your final calculation and your final answer shall be that XR equals to 1.0625. Alright, so thank you for watching this video and see you soon.